Hey guys, or rather my team. It is me, Team Lead, your friendly neighborhood genius, playboy, philanthropist. And today I'm going to explain you very simple, at least in my mind, topic. It's actually one of the four pillars in objective programming, abstraction. So what is abstraction and how you understand it? I think this image illustrates it quite well. When you're looking at abstraction, you're not quite sure what you're looking at and what it did that. So we'll be going through, I would say, three different layers. So one layer would be Wikipedia definition, the other layer would be, let's say, humanized understanding of what that is, or rather we'll start by humanized explanation and go through Wikipedia, and we will go to in-depth explanation and I'll show you how that looks in language. So let's start. So first of all, it is really good to understand the word itself, so what it is. So if you're not sure, you can always Google that, and if you insert into Google an abstraction, it says abstraction, noun, the quality of dealing with ideas rather than events. Or a second explanation, freedom from representational qualities in art. So these two examples are more or less tied to art as such, but we wanna to tie that somehow to software development. So let's think for a second. Don't do anything else. Just what an abstraction means for you. Does it mean to hide something, to change something, to let's say only see parts of it? Just first of all, let's always start with what does this word mean for us and how we understand it ourselves, and from this explanation we're going to move forward. So I myself understand abstraction as a hidden inner working. So for me, if you were to ask Team Lead, what is the easiest definition of an abstraction, I would say, like one sentence definition would be to hide inner or general workings and only display the more specialized outputs as such. So you kind of see something and you don't really care how it works. So for me, to put it simply, that's an abstraction. So first of all, let's try like real world example and how it can look in real life, because it's most important. Usually people try to explain and look at the software and software definition and see how to make that into real life. It's actually the other way around. If you want to understand something, how it works and why it works, just look at real life and you'll understand. So for example, here is a remote control, it's from my TV. It's a Samsung remote control, right? And if it has a lot of buttons, and if I press a button, some action happens. We don't know, we don't care. If we go into nitty-gritty, we understand that when you press a button, there's probably some kind of sensor which takes that passes that electrical, like something through electrical circuit. There's probably some board here. It changes that click into signal through this amazing thing at the center here. It passes the signal as specialized signal to the TV. There's a receiver bulb here which receives that information. It interprets and etc. etc. So you can understand even in this small device how many levels of abstraction that goes. So for us as a user, we don't really care how that works. We use the highest level of abstraction, meaning that we press a button and there's nothing more to abstract here unless you can add your thoughts, let's say like Elon Musk's Neuralink, and you can think about pressing a button and that happens. But if you don't have that, I would say this is the highest level of abstraction. So it is super specialized. So you have very specific buttons which do very specific things. So to go through this abstraction into something generalized, and you make things happen on TV set. So as you can see, this is, I would say, quite clear explanation. Just you don't really need to understand how it happens. You just need to understand that this is the, let's say, highest level, and the lowest level is somewhere on the TV set where the circuit actually changes the TV channel and pixels in the screen refreshes with new information. So that would be the lowest. So from TV remote to passing a signal to inner workings of television set, that's like real world example of abstraction right here, right now. So we can try to move on through let's say our real explanation, and let's go into how it's defined by Wikipedia. I really am amused by most of this explanation. So as you can see, if you go into abstraction and you try to see what is meaning in computer science, it's a bit dodgy. It says in software engineering and computer science, abstraction is the process of removing physical, spatial, temporal details or attributes in the study of objects or systems to focus attention on details of. I mean, you lost me there. This is just a lot of information here. Maybe the rationale would explain more. So rationale says computing mostly operates independently on concrete world. Okay, the hard implementations, the central form computing language abstraction, new artificial developed modeling planning. I mean, I really understand why even some junior developers don't really understand and reading such things, because I think most of these things are made by people who already understand it for people who already understand it. So I would say what it should say here, it should say what you're doing or what it means in computer science. You're abstracting from lower functions to higher functions. So essentially, if there's a function to read, let's say, data object from database without taking care of logging or breaking or anything like that, that's the lowest level. And if you go through that level to a level where you just receive JSON as an object, that's the highest level of abstraction. So it's actually as simple as that. You don't need to go into deeply. So if I were to rationale for that, it's quite simple. First, if you put everything in one place, it will look like very ugly. Imagine like one class where you put all of that code. And if you need, let's say, logical rationale, why we would use abstraction and why that makes sense, think of it again. As I said, I would say two keywords are super important to understanding abstraction is general and special. So to understand those two things in abstraction go, let's say, hand in hand, or leg to leg, depends on what kind of sayings you like more. So if you have something very broad and something very general, and you move from that let's say generality or general things to something so special, so specialized that it already does one thing. So if you have, let's say, lowest abstraction layer where you can input let's say ones and zeros to basically move bits in the computer innards, and you have, let's say, super specialized JavaScript which runs in your browser. So think for yourself how many levels of abstraction that goes through, right? So let's say we have machine code, then we have some kind of compiler, let's say assembler who does that, let's say, the lowest form of code. We have, let's say, another language which abstracts that into something more useful. For example, we have C, and C helps us, with more frameworks, with more libraries, more things added without just, going to and moving stuff there. We also have, let's say, C++, which again adds a little bit more and abstracts a little bit more, in the sense that we can still, let's say, break our computer by mismanaging memory, but we are not doing all of it in that language, And for example, if we move one more abstraction level up, we could get a language which is called, for example, manage, and managed for the reason because you're not managing memory. So for example, C# would be another level of abstraction, and it would be managed language, so to speak, in a sense that you are not working with memory as such. So you're writing your force, you're writing your different iterations, you're writing your list collections and all that, and you don't really care how that translates, and you don't really care if you're using too much RAM, as an example. So that's one level of abstraction. Now another level of abstraction could be a software program which uses that C# code. For example, let's say if we were to build browser, which uses that C# code, and that browser inside could have, let's say, JavaScript compilator, right? And we are open a browser. For example, let's open browser right here. As you can see, we have a console, and we can say, for example, var, or let's say let, because that's newer and better. Let's say a equals 1, right? And we go a, it is 1. How cool is that? So we just declared a variable inside our console, which lives in our Chrome browser, which lives in our Windows, environment, and down the line we go. So this is I think this is a great way to explain this, just going through different levels. And again, as I said, 2 keywords. So general, something where everything basically goes and nothing can happen, and something very specialized, and it's even abstracted in a way that more abstraction layers you go, sometimes it's even impossible to reach the, let's say, first level of truth. So for example, if we were to use console, it is impossible to mismanage memory here, because this runs on the specific environment which only exists in this browser, so it doesn't even have direct connection. So this is, if you were to ask me, okay, so what is the easiest abstraction violation? So I would say this example works absolutely correctly. If you could somehow like destroy your Windows by inputting some very bad JavaScript command here, and it could actually break your environments, I would say that's the easiest way to break abstraction, because that way, if you can reach the lowest resource, abstraction kind of doesn't exist, and this is where it doesn't work. So yeah, so we gone through level 1, where we saw kind of how it would live in the real world. We went through a sort of a kind of development where I just explained you and showed you a few explanations, and I can even now go and show you in a code, because that's the best part. So I have this like thing written here. It doesn't mean much. It's just pretty much a random thing. So do not pay too much attention to this. I'll just go and explain. So we have our program. So it's like a starter class. It doesn't mean much. And you can say, okay, so how can even in the smallest let's say program, how can we do abstraction? So quite easy. Imagine, let's say we have few different things we want to use. So we have a code here which does something. It reads keys and it outputs, it writes something to the console, and everything's here. So what if we want to do it in a correct way? So we would definitely use abstraction in the sense that we would make let's say printer, right? We're making a printer class, and our printer class can hold all of our things. So let's take it here. Let's maybe this one too. So we take this code here. Okay, I forgot something here. Let's take this and we input here. So it will say that this is not something you can use here. So we'll fix it. Don't worry. And in this way, by inputting things, you can already see that we're moving away. We're moving things. So let's make a method for our printer. So for example, let's call it public void method print, and we're going to put all of that beauty into our print. So we did like so, and now what we have a let's say printer, and our printer can print. So for example, if we go to program, we say we want to make new printer, our new printer, let's say a new printer. We use that, and when you have new printer, we can probably call a method to print, right? So what it does, let's run it to see if we didn't misspell something. So if it works, it shows in my native language. It's enter 2, and it says your key is 2, operator, let's say plus, and second will be 2. Oh, and you see we kind of have a small calculator, so maybe just instead of printer, let's rename it for understanding same calculator. So it adds things, so let's call it calculator. Let's rename this to calc, and our printer is now calculator, and it calculates two numbers. So you can say, right, but it's just, what you did here is exactly the same. Yes, you are right, we just moved and nothing super amazing happened, but this is just, let's say, one level of things. So for example, imagine we want to build something rather more elegant. So if we were talking about, let's say, databases, we would definitely have something like the lowest level where it inputs things and gives you an output, somewhere where it's get validated or probably changed, and another level can be where all of the communication happens. So for simple applications, when you're displaying things like this, it's harder to understand, because what you're seeing here it's a mock code. It's hard to understand where that abstraction. So let me show you in a little bit more real, so to speak. Where is that? I've been making this mock application for one of the interviews, so I'll show you code here and you'll understand where that abstraction is coming. So let's go into our store controller, right? So how it all goes down into, again, this is semi-real project. It's not a real project in the sense that it's never going to be live, but it's a bigger or more advanced project than the one where we just saw. So what we have here quite simple things. We have a controller. So controller receives data and it can give data to you. But what it does here, it validates it. So at this specific level of abstraction, what we're doing here, we're validating. So for example, if someone is passing us a query which is empty, so essentially our service as such, as a place which can give you data, expects to give you a correct command, right? And if you give a command which is incorrect, we say query should not be empty or null. So on this layer of abstraction, it's a very specialized layer. In this very specialized layer, we receive data and we validate it. So this is the why it's needed here. Now, if you go one level below, so now we are entering, let's say, we're getting closer to the meat of things. So here, when we receive commands, we do something. So here, as you can see, we read store. We do some kind of conversion with date times. So we're doing something here. So we understand that validation happens a bit upper and the higher level, and on a lower level we read store. On this specific, let's say, middle layer, we are changing one data object to another. So for example, we receive from the database specific entities, how it looks on the database, and on our front end, or let's say on our business layer, so to speak, we may need different things, and one don't really need exactly the same as being stored in the database. So here we're changing. So here we have a store model, and we're doing different things, because if you read to store DB, we can go to the interface and it returns something else. If you go to implementation, now we are in the lowest, it should return, as you can see here, store entity. Here is store entity, and here is store model. So we receive store entity from database and we change it to store model here. So it's a middle layer abstraction, and if we go to the lowest level of abstraction, that's going to be our, let's say, database layer. So in this layer, basically what we're doing, so it's commented out, don't really see it, look at this, it's work in progress, but what we're doing here, we're receiving data. We're just taking data from database, and we are packaging it in an entity or entity format which we understand. So this is kind of real example how we can see at least 3 levels of abstraction. And again, I'm not talking here on the hidden 4th level where there is an actual MySQL connector who takes those things, how they look in database. It definitely has a logic how it sees it, but for us it's abstracted in a way that we are not controlling this, so I'm not even mentioning. But if we would be truthful for ourselves and how it actually works, MySQL connection is also another level of abstraction. And if you were to go into its sites and see how it works and what kind of objects it has, you would definitely understand that it's definitely amazing thing, because I'm gonna give you a hint here. It has its specific entity mechanism also. So for you, I hope this was helpful for you, and you understood something here. I do hope that those 3 levels really help you. And always remember, first of all, always look in the real world. Always, it's not about how programming does it and how to change programming, or rather convert programming into real world. It's actually the whole idea of programming is to look at the real world and see how we can automate it. So if we have working successful processes, we can definitely make software for that. So level 1 is understand that there's an abstraction everywhere you go, even in your house where you push buttons for your TV. There's a bit harder to understand abstraction where you go through different applications or different specific languages which does specific things. And like lowest level of abstraction, or our level 3, is how it actually looks in our code. So if we take something and we try to abstract it. So yeah, guys, I hope you like this. If you like this video, do press like. It helps the algorithm, because I don't have that many watchers per se now. You can definitely subscribe. I'll be putting more videos and more explanations. So thanks for watching. Have a nice day, and I hope you did understood something. Cheers.